All right, guys, I want to start off by saying sorry about the tech issues today. Again, no pressure. Hopefully now we know a little bit of a format for what's going to happen if Zoom freaks out, okay? I did release the notes to you guys earlier, so you did get that, but I want to make sure that, you get the same instruction that the in-person guys got during class today. So, again, I'm not sure exactly where we cut off, but we were going over the rules, the basic rules we had for sig figs, right? And I know we got through that. And what I was pointing out was that if you look right here, okay, obviously there's the rules in this worksheet I released to you yesterday as well, all right? So there are the rules with a couple extra examples. So either you have the notes that we wrote above with my phrasing or wording, or you could have this as well. Okay, so moving forward down here, I just want to go through and make sure we're getting the correct answers here. Okay, so for this one, it's asking to determine the correct number of sig figs. And what I'm going to do to help you is I'm going to highlight exactly what values are sig figs, or underline, right? So for this first example, just this 2 is determined as a significant figure, versus down here, it's this 2 and 0. Because again, both number 1 and number 2 are the exact same value. All right, they're both the exact same value, but with number 2 there, you put a unnecessary 0 at the end. So this 0 is unnecessary, right? It's there by choice, not by necessity, versus these first 2 zeros, okay, are there by necessity, okay? For this one here, 501, that's 3 significant figures, because obviously 5 and 1 are significant always, and then the 0 sandwiched in between, which makes that one also significant. Then if we look at 4 here, 501 and 501.0, again, are the same number, just shown in 2 different ways. And of course, by putting that 0.0, we also make that a significant value. So there's 4 of those there. Okay, for number 5 here, we're looking at 5,000, right? So that would be 1 significant figure, because those zeros are there by necessity, not by choice, and we didn't denote it with a decimal place. All right, versus if we go over here, look, 5,000 decimal place, right? That extra decimal place there was on purpose, because we wanted to say that those 3 zeros were also significant. So that would make this 4 significant figures. All right, same thing here, 6,051.00. So that makes all of those significant. So we're going to have 6 significant figures on that one. Now, looking at number 8 here, 0.005 or 0005. Okay, those first zeros are there by necessity. Okay, they're there by necessity to denote where that 5 is located. So there's only actually 1 significant figure in this example. All right, next one here, 0.1020. Okay, again, that last 0 is unnecessary and was there by choice. So that makes this 4 significant figures. All right, and then 10,001. So again, sandwich between all those ones, make those zeros also significant. So that makes this 5 significant figures. Okay, so then for this next one here, we're going to determine the location of the last significant place by placing a bar over that digit. So if I go down here, okay, 8,040. All right. This 4 is the last significant digit. Again, that last 0, this 0 right here, that is a placeholder. So it is there by necessity, not by choice. All right, now 0.90100, those last 2 zeros are there by choice. So that makes that last 0 the last significant digit. All right. 3.01 times 10 to the 21st. Okay, the last significant digit of this is that 1, right? Because that times 10 to the 21st does not count as significant figures. All right? It does not count in significant figures. If we go over here, 0.0300, again, those last 2 zeros are there by choice, which makes them significant. All right, now looking at 90,000 and 100, okay, there's no decimal place and zeros aren't always significant, so our last significant figure there is that 1. All right, 0.000410, again, zeros there by choice, not by necessity, so it makes it significant. All right, and this one, 17, obviously 5 is our last significant figure. Okay, another scientific notation one, so 4.7 times 10 to the negative 8, that makes this 7 a significant figure. All right, 2.00 times 10 to the second. All right, so again, those 3 zeros after the decimal place are there by choice. So that makes this the last significant figure. All right, and then 10,800,000.0. Again, unnecessary to have this 0.0, so that makes this digit significant. All right, so that is this worksheet here. Again, this is just for you and for your notes. So if you're not getting this and this isn't making sense to you, you really need to go back through and relook at some notes here or ask some clarification questions tomorrow. All right. Now, moving forward here, we're going to do rules for sig fig calculations. Okay, rules for significant figure or calculations with significant figures. All right. So we're going to split up these rules based on what type of calculation are we doing. Are we doing addition and subtraction, or are we doing multiplication and division? All right, so our rules for addition and subtraction are pretty simple here. All right, the answer is based on the least number of decimal places. And I'm going to abbreviate this as DP, so decimal places. All right, so a way that we can think about this here, if we were to write it out like you guys did when you were in probably middle school, is the last time you saw it written out like this. All right, 2.9975. All right, if I add this all up here, my answer is 5.4125. Okay, but we're going to go through and look at significant figures. Or sorry, for this one, it's not significant figures, it's decimal places, since we're doing addition. All right, so I have 3 decimal places here, 2 decimal places there, and 4 decimal places. So my final answer should have the least number of decimal places. So we should actually round it to 2 decimal places. All right, and something you could think about is if I drew a dashed line at the least number of decimal places. Okay. And obviously, that's the cutoff point. And we need to figure out how to round this number. Are we going to round it up or are we going to round it down? And obviously, that's based on that number there. Okay, so since you know that 2 is less than 5, we're going to round this number down. So our final answer is 5.41. All right, and that would be the correct way to show that with proper sig figs and decimal places. All right. Going to the next problem here, if we were to do a subtraction problem, so 5.9 minus 0.221, again, answer in the calculator, we're going to look at decimal places. So there's 1 decimal place there, there's 3 decimal places there. Again, if I were to draw this down, my final answer needs 1 decimal place. So my final answer is 5.7. Again, we're going to round up on the 6 because of that 7 there. All right. So that would be how you do an addition or subtraction problem. Okay. Now, if we're looking at multiplication and division, all right, this has your answers being based on the least number of sig figs. Okay, least number of sig figs. And again, we're going to abbreviate that as SF. Okay, so it's based on the least number of sig figs. So if we were to do a problem here, all right, maybe 1.0 there. Okay, if I were to actually plug this in my calculator, it would give me a value like 6.728, yada, yada, yada. All right, so what we're looking for then is obviously the least number of sig figs. So we would go through, oh, this has 4 sig figs, 5 sig figs, 2 sig figs. So obviously my final answer needs to have the least number of sig figs, which is 2. So my final answer for this would be 6.7. Okay, it'd be 6.7. All right, doing a division problem, 2.0035 divided by 3.20. All right, that would give me in my calculator something that looks like this. All right, and I'm going to, of course, look for sig figs. So I have 5 sig figs here, 3 sig figs there. So my final answer needs 3 sig figs. So I'm going to round this to 0.626. Okay. And of course, unless I asked you to show me all of this work, you don't actually need to go through and label them as how many sig figs, how many decimal places for each of the values here, okay? But obviously, as we're going through this, I'm going to do this and show you every single sig fig and decimal place, just so that, again, I'm as clear as possible. All right. So, moving forward here, okay, I released this to you earlier, so maybe you got started on it, maybe you didn't. Again, put your name on it just to get in the habit of it. And of course, like the other worksheets, it has the rules at the top, but I wanted to actually walk you through a couple examples and the definitions here. But again, it's based on least number of sig figs or least number of decimal places. So, I gave the guys in class some time to work on this. So what I would suggest here is that you actually pause the video, try to work on these problems, and then look at the answers. So again, I would suggest you pause, work on it, then come back and look at the answers. Okay. So hopefully you guys, like I said, hopefully you paused, worked on it, and got through. I want to walk you through how to do these problems here. So the first thing that I would notice, okay, and again, I'm going to annotate this for you, the process that I go through in my head. All right, first thing I would notice here, it's a multiplication problem. So it's going to be based on the number of sig figs, right? So it's going to be based on lowest number of sig figs. So the next thing I do is I go, okay, 3 sig figs, 4 sig figs. All right. So when you calculate your answer, whatever it is going to have the least number of sig figs, and that would be 3. Okay, so I'm going to have 3 sig figs. All right. Then you can either do this calculation in your calculator, get the final answer, call it a day, or what you can do is do your units next. Okay, it doesn't really matter to me, whatever your process. I personally would do the calculator first, but again, that's just me. So I plug in 1.35 times by my 2.467, right? And that's going to give me a final answer, and I need to express it in 3 sig figs. So this final answer here is going to be 3.33. All right, and since it's multiplication, I have meters times by meters, so that's going to give me meters squared. Okay, that's going to give me meters squared. All right, for this next one here, I've got a division problem. So again, division is based on sig figs, right? So I have 4 sig figs here, 2 sig figs here. All right, so my final answer obviously needs to be in 2 sig figs. All right, so I would plug this into my calculator and get out a value. All right, and the calculator is telling me it's 24.64. Okay, so I would round that up to 25. All right. But now, just a reminder for units, I've got meters squared over meters. All right, so essentially that's like writing meters times by meters over meters. And we should know by now that if we've got a unit on top and the same unit on bottom, we can actually cancel this out. So we are left with 25 meters. 25 meters. All right. Next one here is an addition problem. So that means it's going to be based on decimal places. So looking at this problem here, I've got 2 decimal places, 1 decimal place, and 0 decimal places. So of course my final answer needs to have 0 decimal places. When I plug it all in, okay, I get 53.21, which should be final answer is 53. Okay. Number 4 here, it's a subtraction problem. So again, it's going to be based on decimal places. So I've got 2 decimal places and 1 decimal place. So of course my final answer needs to be in decimal places. Or I'm sorry, it needs to have 1 decimal place. All right, so my final answer for this would be 26.6. All right. Oh, and something I forgot above, apologies, is my units. So if I go back up to 3 here, it was milliliters plus milliliters plus milliliters. Obviously, my unit's going to be milliliters, capital L, lowercase m, capital L. All right, next one here is going to be grams. Grams. All right, so 26.6 grams, G. All right, moving on to this next one here. Okay, it is a multiplication problem, so it's going to be based on sig figs. So I've got 2 sig figs, 2 sig figs, apologies, and 4 sig figs. So obviously my final answer here needs to be with 2 sig figs. All right, so I'm going to plug that into my calculator. All right, and I get out a final answer of 0.67. All right, now I've got centimeters times by centimeters times by centimeters, so centimeters cubed. Centimeters cubed. All right, the next one is an addition problem. So again, based on decimal places, plug into my calculator. I know this is getting repetitive, but that is the point. All right, so I've got 2 decimal places, 2 decimal places, and 4 decimal places. So of course my final answer needs to be in 2 decimal places. So my answer is 3.35 centimeters. 3.35 centimeters. Okay, now this one is a division problem, so it's going to be based on sig figs. So I've got 2 sig figs there and 1 sig fig there. So my final answer actually needs to be in 1 sig fig. All right, when I plug this into my calculator, I get out 37.5. So 37.5. All right, but I need to actually round this up, so I only get 1 sig fig. So my answer is going to be 40. All right. And then I've got liters cubed. So that's like saying liters times by liters over 1 liter. Cancel, cancel. I'm left with liters squared. All right. Now the next one here is a subtraction problem. So again, based on decimal places. 0 decimal place, 2 decimal place. Final answer needs to be in 0 decimal places. All right. So I've got 54.7 or 55. 55. My unit is kilograms. All right, only 2 more here. It's a multiplication problem. It's based on sig figs. All right, so 4 sig figs, 3 sig figs, 2 sig figs. All right, when I plug this into my calculator, I get out 0.0017. All right. Again, because my answer needs to be with 2 sig figs, and my units are millimeters cubed. Millimeters cubed. All right, and then finally here, remember, this is scientific notation. Okay, that's scientific notation, so it's not a multiplication problem. All right, it is a division problem, which again, still follows the same rules of, oh, not decimal places, got excited there, of sig figs. All right, so I'm still following the rules of sig figs. All right, so what I'm going to look for is, of course, I've got 4 sig figs there, I've got 5 sig figs there, so my final answer needs to be in 4 sig figs. All right, I would plug this into my calculator, and I will get out an answer of 8.958. All right, I need my answer in 4 sig figs, so 8.958. Okay, and then my units, I've got meters squared over meters, so my unit is meters. Okay, so again, this is a way of doing the sig figs with calculations here. Okay, something I really want to highly stress to you is that if you do everything right, so if you plug in everything right on your test and you just give me your answer with, let's say, the wrong number of sig figs, okay, if it's a 10-point problem, you're going to lose 1 point, right? So you still get a 9 out of 10, which is an A, but obviously it's not as great as you'd like it to be, right? So it's the difference between an A plus and an A minus, or an A and an A minus, okay? Similarly, if you do everything right, you give me the proper number of sig figs, but you give me the wrong units, okay, that's another point right there. So again, you do wrong units, you do wrong sig figs, you're automatically at an 8 out of 10, okay? And then lastly here, like if you have everything's right, correct number of sig figs, correct units, you just maybe plugged it in your calculator wrong, okay, that's like half a point, not the biggest deal in the world, all right? Again, that's why showing your work is going to be super, super important, okay? Now, the last thing that you missed here is that I would really, really like if you guys could try to look up the answers to some of these, all right? Again, I'm asking you to do it for a little bit of homework here maybe, or at least to start generating some ideas as to what your answers might be, because obviously you saw it already. This is the worksheet for dimensional analysis and what I want to talk about tomorrow, okay? It's not a super long worksheet, but dimensional analysis can be a little bit trickier. So if we get through these questions faster at the beginning of class, that's more time you have to work on your worksheet, okay? So the questions I want you to look up or at least start thinking about is, what is dimensional analysis? Okay, in a sense, in general, what is dimensional analysis? All right. Number 2, what and or how does it work? So why and or how does it work? So why does dimensional analysis work, or how does dimensional analysis work? All right. Next, what do we need in order to be able to do dimensional analysis? Okay, what do we need in order to be able to do dimensional analysis? All right, and then finally, how do we cancel units? Right, so we worked a little bit with that earlier, but again, try to give me it in your own words here. How do we cancel units? All right, so that pretty much ends this video here. Again, the notes that we took today in class or that you saw on the video, those notes are straight up for you. Okay, those are straight up for you. And one of the suggestions I made to the class is that if you are struggling with sig figs, okay, if you are struggling with sig figs, maybe take and copy your notes or these pictures up here of this kind of stuff. Sorry, it's moving around here. Maybe take your notes like this, or take pictures of these and put it in a separate note just based on sig figs, so that way you can reference it when we're doing things in class. Okay? But other than that, if you've got any questions, please feel free to reach out. Again, please consider looking at these questions so we can have a better discussion tomorrow. All right. Other than that, goodbye.